In this section, we're only going to consider simple examples of probability density functions. Examples where we can calculate the areas that we're going to need to calculate, find the probabilities, using simple formulas that we know from geometry. So let's consider this problem. Consider the continuous function defined by y equals 0.1 on -4 less than or equal to x less than or equal to 6. So what does this mean? So we have a function here, and it ranges between x equals -4 and x equals 6. Okay, we could see that. Let me get my drawing here. We could see that here, right? There's x equals -4. There's x equals 6. The function itself is y equals 0.1. That describes how high the function is. Notice it's at 0.1 here on the y-axis, and it always stays at that height. So the graph is just showing us what this statement is describing. Okay? We want to find the total area under the function. So we want to find this area here. Now this area is relatively straightforward to find because it is a shape that we know well from geometry. This is a rectangle, and we know that the area of a rectangle is just the base of the rectangle times the height of the rectangle. So all we need to do is find the base and height. The height is pretty easy. We just look at how high we're going. We go all the way up to 0.1. Okay, so that's how tall this rectangle is. That's the height. Okay, base is a little trickier just because we're not starting at 0, right? We start at -4, we go to 6. The general rule of thumb for calculating the distance between two values is start with the bigger value and subtract the smaller value. So 6 minus -4, that's 10. That's the length of the base. So if I put those together, I get 10 times 0.1. So base is 10 units, height is 0.1 units. If I evaluate that, then the total area underneath this function is 1. Okay? So based on this calculation, is this function a probability density function? Does this function represent a probability density function? Now, there are a couple things we need to check for. First, remember that the whole function has to be above the x-axis because we want it to measure the area below the function and above the x-axis. That becomes hard if we go below that x-axis. Now, we don't have to worry in this case. It is entirely above that x-axis. It's entirely above this horizontal line, right? The other thing is it's a probability density function. It represents probability, and we just calculated all of the area underneath that function. All of that area should represent all possible outcomes, the probability that any outcome happens. Whatever this experiment is, if we run it, there is a 100% chance that something happens. So the total area should be 1. And that is what we get. So because this is equal to 1, yes, it is a probability density function. If this were anything other than 1, then this couldn't represent a probability density function because the total area underneath would not represent all possible outcomes of an experiment. It would not represent 100% of all possibilities. So the total area has to be 1 for this to be a probability density function.